of planetary motion. First is the law of orbit. Every planet revolves around the sun in elliptical orbit, and sun is at its one focus. So if I can make it a bigger one, this is an ellipse. Then we have this as the major axis, this as the minor axis. So we have, for ellipse, we have two focus or foci, you can say, one here, one here. Then the first law says, which is the law of orbit, that every planet revolve around the sun in this elliptical orbit when sun S is at one focus. This is known as the perigee or perihelion. This point is known as the apogee or aphelion. The planet is nearest to sun at perigee. It is farthest from sun at apogee. Then the Kepler, another law, which is law of area. The radius vector drawn from the sun to planet, it will sweep equal areas in equal interval of time. This means the aerial velocity of the planet around the sun is constant. Means if at t time it reaches from this point to this point, this is the area. Okay, so the radius vector drawn from the sun to a planet sweeps equal area. If for the time, say same time t, this is the area, then these two have to be equal. This is the law of area. So aerial velocity of a planet, dA by dt, area per unit time, in terms of derivative. This is L by 2m, which is constant. L is nothing but the angular momentum and m is the mass of the planet. Law of period. This says that t square is directly proportional to a cube, or you can say r cube. The square of the time period of revolution of planet around the sun is directly proportional to the cube of the semi-major axis of its elliptical orbit. See, in this case, this is the major axis, so this half is the semi-major axis. This whole is B, you can say 2B. This is minor axis, so the half of semi-minor axis, or you can say half of minor axis, is semi-minor axis, which is B. So if you consider from this point to this point as 2a, this is the distance we are talking about, a. So t square is directly proportional to a cube. So you can say for t1 time, if it is equal to say k a1 cube, for t2 time we have again k a2 cube. So if you divide these two, t1 by t2 whole square, this is square, is equal to a1 by a2 whole cube, where a is the semi-major axis of the elliptical orbit.